Hey, this is Ryan from Reality School. In this video, we'll go over how to create a settings view to enable or disable advanced AR features such as People Occlusion, Object Occlusion, and LiDAR Mesh Visualization. When completed, our app will display a grid with toggle buttons that allow the user to turn on or off, the ability to render a virtual object behind people who are in front of the camera, the ability to render parts of the virtual content not obscured by real-world objects from the camera's perspective, and the ability to visualize the mesh created by the LiDAR scanner. Before we get started, this is the hardware and software used in this video. If you're using anything older or newer, you might have to make some adjustments to your code. We have several action items for this video. First, we'll update the FocusEntity package to the latest version. Second, we'll create a SessionSettings observable object with published variables. Next, we'll put a SessionSettings StateObject in our app environment. After that, we'll add a SessionSettings instance to the preview provider in ContentView. Next, we'll create a SettingsView with a grid to display toggle buttons for enabling or disabling advanced AR features such as People Occlusion, Object Occlusion, LiDAR Mesh Visualization, and multi-user experiences. After that, we'll update the Settings control button in ControlView to trigger the display of a sheet with a SettingsView. And finally, we'll update our CustomARView to enable or disable advanced AR features for our AR view. So without further ado, let's get started. For the first action item, we'll update the FocusEntity package to the latest version. Right-click on the package and select Update Package. At the time of this recording, the latest version of the FocusEntity package is 2.2.3. Keep in mind that when updating a package, your code might break if fundamental changes were made to the package. If this happens, take a look at the README of the package on GitHub. Usually, the developer provides documentation on how to use the latest version of the package. At this point, you might also be wondering why we're even updating this package if our app was working fine with an older version. Developers tend to update their frameworks and packages to fix bugs and add new features. So unless the new version will absolutely break everything in your app, it is a good practice to update to the latest version from time to time. For the second action item, we'll create a SessionSettings observable object with published variables. We'll start off by creating a SessionSettings class. To do so, we'll create a new file. Right-click on PlacementSettings.swift and select New File. Select iOS as the platform and SwiftFile as a template. Click Next. Give the file a name. In this case, we'll call it SessionSettings. Click Create. We can remove Import Foundation and instead import SwiftUI. Create a new class called SessionSettings and have it adopt the ObservableObject protocol. Our class will have 4 Boolean properties. The first property will be a published variable called isPeopleOcclusionEnabled, and we'll have a type of bool. We'll also initialize this property to false. Next, we'll copy and paste our published variable 3 times. The second property will be isObjectOcclusionEnabled. Next, we'll have isLiDARDebugEnabled. And finally, we have isMultiUserEnabled. Our SessionSettings class is now complete. For the next action item, we'll put a SessionSettings StateObject in our app environment. To do so, we're going to create a StateObject in our top-level app instance. We're going to open up our ARF app Swift file. This is the main entry point for our app. If you've ever built iOS apps with UIKit, the app file is comparable to app delegate for UIKit. Let's create a StateObject for SessionSettings. Next, we'll use an EnvironmentObjectView modifier to put the SessionSettings StateObject into the app environment. By doing this, we don't have to pass our data model through many layers of our view hierarchy. For the fourth action item, we'll add a SessionSettings instance to the preview provider in ContentView. This will ensure that our preview doesn't crash when using the canvas to preview our app. We can now move on to the next action item. We'll create a SettingsView with a grid to display toggle buttons for enabling or disabling advanced AR features such as People Occlusion, Object Occlusion, LiDAR Mesh Visualization, and multi-user experiences. To do so, we'll create a new file. Right-click on PlacementView.swift and select New File. Select iOS as the platform and SwiftFile as the template. Click Next. Give the file a name. In this case, we'll call it SettingsView. Click Create. We can remove Import Foundation and instead import SwiftUI. The first thing we'll work on is an enumeration called Setting. This enum will contain the various available settings to be displayed in our Settings grid view. For this app, we'll list 4 cases. We'll have People Occlusion, Object Occlusion, LiDAR Debug, and Multi-User. Next, we'll create a new variable called Label and set the type to string. This variable will return the label text for each case using a switch statement. For case People Occlusion and Object Occlusion, return Occlusion. For case LiDAR Debug, return LiDAR. For case Multi-User, return Multi-User. We'll create another variable called SystemIconName and set the type to string. This variable will return the SF symbol icon name for each case using a switch statement. For case People Occlusion, return Person. For case Object Occlusion, return cube.box.fill. For case LiDAR Debug, return light.min. For case Multi-User, return person.to. We are now done with our settings enum. Next, we'll work on our setting toggle button. Right below our setting enum, create a new struct called setting toggle button and have it adopt the view protocol. To conform to the view protocol, add a body variable and use Xcode autocomplete to help you along. Before we populate the body, we'll declare two properties. The first property will be a constant named setting and will have a setting type. The second property will be a binding variable named isOn and will have a bool type. Inside the body, we'll create a skeleton for our button. In the action block, we'll toggle the isOn boolean variable. The toggle method is a convenient method that toggles the boolean variable's value. We will also add a print statement that logs the file path, the setting, and whether the updated isOn value is true or false. In the label block, we'll create a vstack to display an icon image and a text label right below it. We'll create an image using the system name constructor and pass in setting.systemIconName. We'll use several modifiers to style our image. First, set the font to the system font with font size 35. Next, set foreground color to green if isOn is true, or else set it to color UIColor.secondaryLabel. And finally, set the button style to plain button style. We'll set our text to setting.label. Again, we'll use modifiers to style our text. First, set the font to the system font with font size 17, weight set to .medium, and design set to .default. Next, set foreground color to color UIColor.label if isOn is true, or else set it to color UIColor.secondaryLabel. And finally, set the padding on top to 5 points. To wrap up our setting toggle button, we'll add some modifiers to the button. Set the frame width and height to 100 points, the background to color UIColor.secondarySystemFill, and finally a corner radius of 20 points. Now that our setting toggle button is complete, we can work on the grid view that will display our buttons. Right above our setting toggle button struct, create a new struct called SettingsGrid and have it adopt the view protocol. To conform to the view protocol, add a body variable and use Xcode autocomplete to help you along. Before we populate the body, we'll declare two properties. First, let's declare a SessionSettings property with the environment object attribute. Second, we'll create a private variable named gridItemLayout and assign it an array with a single grid item element. This grid item will be adaptive with a minimum and maximum size of 100 points and a spacing of 25 points. This essentially creates a grid layout that tries to fit as many square cells of size 100 on a row with horizontal spacing of 25. Inside the body, we'll create a scroll view that will contain a vertical grid with vertical spacing of 25. We can create this vertical grid using a lazy V grid and pass in grid item layout for columns and 25 for spacing. Inside our lazy V grid, we'll create our 4 setting toggle buttons. The first button will be for the People Occlusion setting. We'll pass in a binding to SessionSettings.isPeopleOcclusionEnabled. We'll repeat the process for the remaining 3 settings. I will speed up the process, so feel free to pause the video here. To wrap up our settings grid, we'll use a modifier on our scroll view to set the padding on top to 35 points. The final step for this action item is to create the settings view. Above our settings grid, create a new struct called SettingsView and have it adopt the view protocol. To conform to the view protocol, add a body variable and use Xcode autocomplete to help you along. Inside the body, we'll add a navigation view that will contain our settings grid. Next, we'll work on our navigation bar. To add a navigation title and button, we'll use modifiers. However, in this case, the modifiers will be added to our settings grid, not the navigation view. First, we'll add a navigation bar title and pass in a text view as argument to the modifier. We'll set the text to settings. We will also set the display mode to inline. Second, we can add our done button by using a navigation bar items modifier. We'll configure it to add items to the trailing edge of the navigation bar. We'll start off by creating a skeleton for our button. Next, we'll work on our Done button action. When we tap on the Done button, we want the settings sheet to be dismissed. We haven't yet created a sheet for our settings view, but that will happen very soon. To dismiss our sheet, we'll need access to a Show Settings State property. We will therefore create a corresponding binding variable in SettingsView. In our Done button action, we can toggle our Show Settings Boolean property. For our button label, we'll add the text that displays Done in bold. For the next action item, we need to update our Settings Control button in Control View to trigger the display of a sheet with our Settings View. In ContentView.Swift, we'll create a new state property in our ContentView struct. We'll call it Show Settings, give it a Boolean type, and initialize it to false. Next, we'll update our Control View constructor call to pass in a binding to Show Settings. Xcode will give us an error because our constructor does not expect an extra Show Settings parameter. We'll fix that. Navigate to ControlView.Swift. In our Control View struct, add a binding property for Show Settings. Update the Control button bar constructor call to pass in a binding to Show Settings. Xcode will again give us an error because our constructor does not expect an extra Show Settings parameter. We'll fix that right now. Scroll down to Control button bar and add a binding property for Show Settings. Build your project. At this point, the error should be resolved and we can now focus on updating our Settings Control button. In our Settings Control button action, we will toggle the Show Settings Boolean property. When we tap on the Settings Control button, we want it to open up a SwiftUI sheet. A sheet is used to present new view controllers modally over existing view controllers. We'll create a sheet using the Sheet modifier. This modifier takes two arguments. One, a binding property which tells the modifier to show or hide the sheet. In this case, we'll pass in a binding to Show Settings. And two, a content closure which returns the view to be presented. In this case, we'll create a settings view and pass in a binding to the Show Settings property. At this point, our settings view should be working properly. Let's run our app to test our intermediate progress. In the console logs, we can see that our toggle buttons are behaving correctly. Keep in mind that while the Boolean properties in session settings are being properly updated, their values are not yet propagated to the AR view. That's what we're going to work on next. The final action item for this video is to update CustomARView to enable or disable advanced AR features for our AR view. Navigate to CustomARView.Swift. Import SwiftUI and combine. Declare a Session Settings property. Note that this is not an environment object, but just a regular property. The CustomARView is not part of the SwiftUI view hierarchy, and so it doesn't inherit the environment. That means it wouldn't be able to access the Session Settings environment object. Therefore, we'll need to explicitly pass in Session Settings to our CustomARView. To do so, we'll create a new required initializer with two parameters. The first parameter will be a frame rect, which will be of type CGRect, and the second parameter will be Session Settings, which will be of type Session Settings. We can now initialize our stored Session Settings property by assigning it the Session Settings initialization parameter. Next, we'll cut and paste all the code from our other required initFrame method into our newly created initializer. Moving forward, we won't be using the old initFrame method, and so we'll add a fatal error with message, initFrame has not been implemented. Given that we are using a new constructor for our custom AR view, we'll need to make two updates to our AR view container in ContentView.Swift. First, we'll declare a Session Settings property with the environment object attribute. Second, we'll update our AR view to use the newly created constructor. We'll pass in .0 for the frame and Session Settings for Session Settings. Now that we have access to Session Settings in our custom AR view, we can move on to the next steps. Given the complexity and the number of steps in this final action item, we'll create sub-action items. These are the remaining steps to complete. For the first sub-action item, we'll update our configure function to enable scene reconstruction if the device has a LiDAR scanner. In the configure function, right above the session.runConfig statement, we'll add an if statement. If AR world tracking configuration supports scene reconstruction for the mesh option, then we want to set config.sceneReconstruction to .mesh. This line essentially enables LiDAR functionality on our supported device. For the second sub-action item, we'll set up subscribers for our published properties in Session Settings. To do so, we'll declare private cancelable objects for each published settings property. Create a private function to set up subscribers for each published settings property. In this function, we'll create a subscriber for each property. Let's start off by creating a subscriber for the People Occlusion property. We can do so in two simple steps. For the first step, we'll access the published property wrapper's projected value by prefixing the name with the $sign. Doing so gives us access to a combined publisher for that property. For the second step, we will subscribe to that publisher using sync. Whenever the property is updated, our closure will receive the new value. Make sure to retain the subscriber by assigning it to the People Occlusion cancelable. If you'd like to learn more about how all of this works, I'll include a helpful article from swiftbysandal.com. As mentioned previously, our closure will receive the new value of the published property. We'll assign the new value to isEnabled. We'll also use weak self to capture self using a weak reference. If we don't explicitly specify to use a weak reference to self, self will be retained using a strong reference. This can be problematic in certain scenarios. It is generally a good practice to use weak self when working with closures that will be stored for an extended period of time. The reason for this is that capturing an object strongly within a closure will cause it to remain in memory for the same extended period of time. Again, if you'd like to learn more about weak self and closures, I'll include another helpful article from Swift by Sandal. Next, we'll create a private function to handle value updates for the People Occlusion property. The function will have one parameter called isEnabled, which will be of type bool. Next, we'll add a print statement with a message that the isPeopleOcclusion-enabled value has been updated. The actual functionality for this function will be implemented in a later step. Finally, call the update function in our subscriber closure. Repeat this process for the remaining published settings properties. I will use copy-paste to speed up the process. However, I encourage you to pause the video and type out the code to get some more practice. We can now call our SetUpSubscriber function in our initializer. For the third sub-action item, we'll populate the update functions for each of our settings in SessionSettings. These functions will enable or disable a specific AR feature. In this video, we'll update our code for Update People Occlusion, Update Object Occlusion, and Update LiDAR Debug. We won't be working on enabling multi-user AR experiences. This will be covered in a follow-up video. Make sure to hit the subscribe button and enable all notifications to be notified when we upload our next video. Okay, let's work on the Update People Occlusion function. The first thing we need to do is verify device support for People Occlusion. Not every iPhone or iPad supports this feature, so we'll use a guard statement to make sure our AR wall tracking configuration supports person segmentation with depth. We can use supports frame semantics to check whether a particular feature is supported. Next, we'll update the current configuration for the AR session. The reason we get the current configuration and don't just create a new config is because we want to retain all other settings in our current configuration. Next, we'll use an if statement to check whether person segmentation with depth is enabled or not. If it's enabled, we will remove .person segmentation with depth from configuration.frameSemantics. If it's not enabled, we insert .person segmentation with depth into configuration.frameSemantics. And finally, we need to rerun the session to effect the configuration change. Next, we'll work on the Update Object Occlusion function. We can use an if statement to check whether occlusion is already enabled. If it's enabled, we remove .occlusion from self.environment.sceneunderstanding.options. If it's not enabled, we insert .occlusion. And finally, we'll work on the Update LiDAR Debug function. We'll use an if statement to check whether LiDAR Mesh Visualization is already enabled. If it's already enabled, we remove .showSceneUnderstanding from self.debugOptions. If it's not enabled, we insert .showSceneUnderstanding. We are now done populating the update functions. As mentioned earlier, multi-user functionality will be added in a follow-up video. For the fourth and final sub-action item, we'll create a function to initialize settings in our AR view. This ensures that whatever defaults we have assigned to session settings are also set in the AR view. Scroll to the position above our SetUpSubscriber function. Create a new private function called initializeSettings. This function will not take any parameters and the return type is void. Next, call each of the update functions and pass in the respective session settings property. So we'll do self.updatePeopleOcclusion and pass in SessionSettings.isPeopleOcclusionEnabled. Repeat this for the remaining three functions. Now that our initializeSettings function is complete, let's call it in our initializer. We'll call initializeSettings above our call to set up subscribers. We are now ready to test the app. Make sure you have a physical device selected in your active scheme and press Run. We'll open up our browse view and select a model for placement. I'll pick this white chair and place it in the scene. In this case, I place the chair behind my standing desk. As you might have noticed, the chair doesn't visually appear behind the desk. In augmented reality terms, we say that the real-world desk should occlude the virtual chair, meaning it should not display parts of the chair that should visually be obstructed by the desk from the camera's current perspective. Let's open our settings view and enable object occlusion. We see that the toggle button is now enabled. When we go back to our AR view, we can see that the desk is partially occluding the chair. As we move around our device, more or less of the chair is visible. This makes the illusion of augmented reality more believable. At this point, you might be wondering how this actually works. The LiDAR scanner creates an invisible mesh of our space and any furniture or real-world objects in it. This mesh can then be used for object occlusion as we see in this example. To visualize the mesh that is being created by the LiDAR scanner, we can enable the LiDAR debug mode in our settings. We now see the vertices and edges visualized in our scene. As we move the camera around, we can also see that the mesh is being updated as needed. Note that the edges are also color-coded and indicate the relative distance from the camera to that point in space. And finally, let's test people occlusion. We can now see that anytime part of a human enters the scene, any virtual content behind a person is properly occluded as well. I hope this video demonstrates the incredible power of Apple's AR platform and that it inspires you to create some truly transformative AR experiences. And that's it for this video. If this content was helpful and you'd like to support our channel, please give the video a thumbs up. If you haven't already, subscribe and enable all notifications to be notified when new videos are released. Thank you for watching, and until the next time.